The second method in solving second-order linear non-homogeneous differential equations is the variation of parameter method. And this is the variation of parameter. This is the method. Again, the general solution for an equation like that is equal to the solution to the corresponding homogeneous portion plus the particular solution to the non-homogeneous part. Now, if we assume that, if we consider the solution to the homogeneous portion be in this form, then our solution to the particular solution to the non-homogeneous will be in this form: v1x, y1x, v2x, y2x, where v1 prime is that, v2 prime is that, and this w is that. So in order for us to solve this, just by looking at what we need to find out what y1x is. We need to find out what y2x is, which we can find those by solving the homogeneous portion. And we need to know the value of fx, which fx will be the right side of the equation. We need to know the value of a0x, which a0x is the coefficient to the second order, and we need to find w y1, y2. So that's what we need to do. If you write this on the corner of your paper, it will make a lot easier. So now let's use an example using the variation of parameter. Let's look at the equation d2y dx2 plus y is equal to tan square of x. Okay. Let's solve this second order linear non-homogeneous differential equation. So just by looking at the equation, we see that the coefficient of a second order, which is a01, is equal to 1. So our a01 is 1. And the right part of our equation, instead of fx, is tan square x. So our fx is tan square of x. Now, to find the y1 and y2, we need to solve the corresponding homogeneous portion of this equation. So we can use the auxiliary polynomial and write this as m squared plus 1 equal to 0. So m will be equal to plus or minus I. So the roots are imaginary roots. So the solution for imaginary roots will be yc will be equal to c1 sine of x plus c2 cosine of x. So now if we compare this with that, we see that our y1x is sine of x and our y2x is cosine of x. So our w y1, y2, or w y1, y2 is equal to y1x, which is sine x, y2x, which is cosine of x, y prime 1x, which is cosine of x, and y prime of 2x, which is minus sine of x. So this will be equal to sine x multiplied by minus sine x is minus sine square of x, minus cosine of x multiplied by cosine of x is minus cosine square of x. So this is equal to minus sine square of x plus cosine of square of x, which this is equal to 1. So wy1, y2 is equal to minus 1. So this is minus 1. So let me write down the yc here. Yc is c1 sine of x plus c2 cosine of x. Now to find the general solution, we already have found yc. To find yp, we need to find v1x, and v prime 1 is given in this expression, so we have to find v prime 1, then take integration of that and find v1. And we have everything. We got fx, y2x, everything we have. So let's go ahead and find y1, v1 prime of x is equal to minus fx. Fx is tan square minus tan square of x multiplied by y2x. y2x is cosine of x divided by a0 times wy1. So divided by minus 1. So that minus and minus will make it plus. So y prime 1 is that. Let's simplify this. We can write this as sine square of x over cosine of the square of x times cosine of x. Using the formula, we know that the tangent of x is equal to sine of x divided by cosine of x. So using that formula, we can write this tan square like that. Now, we can write this as instead of sine square of x, we can write 1 minus cosine of the square of x divided by cosine of x. Cosine of x and that square will cancel out. So this is what we're going to have. Now we can simplify this further, and we can write this as 1 over cosine of x minus cosine of x. So we can simplify this, write this in that form. Now, this is our v1 prime. So to find the v1 is equal to integral of 1 over cosine of x is secant of x minus cosine of x dx. We know that by definition 1 over cosine is equal to the secant of x. Now, if we look at the integration formula, the integration of secant of x is natural log of secant of x plus tan of x, and the integration of minus cosine of x will be minus sine of x. So this is our value for V1. And our V2, to find our V2, we have to first find V prime 2, then take integration over that and find V2. So V prime 2 is equal to fx, which is tan square of x, multiplied by y1x multiplied by sine of x, divided by 1 times minus 1. So we are going to have a minus here. Now we can simplify this as, we can write this as minus sine square of x divided by cosine square of x times sine of x. So we can write this as, minus, instead of sine square of x, we can write 1 minus cosine square of x divided by cosine square of x multiplied by sine of x. So that will be equal to minus if we divide, we separate that, we can write that as sine x divided by cosine square of x minus sine x. So we can simplify that and write it in this form. Now, let me write the V1 here again. V1 is equal to natural log of secant x plus tan x minus sine x. So we can simplify this a little bit more, and we can write this as minus, tangent of x multiplied by 1 over cosine of x minus sine of x. So again, 1 over cosine of x by definition is secant of x. So we can write that as minus, so v prime 2 is equal to minus tan x multiplied by secant of x minus sine x. Now, for us to find V2, we got to go ahead and integral that. The integration of tan x secant x will be minus secant of x, and the integration of sine x will be cosine of x, will be minus cosine of x, and then we have that minus sign, so this will be minus cosine of x. So this is the value for our V2. So our particular solution for the non-homogeneous portion is V1x, which was natural log of secant x plus tan x minus sine x multiplied by y1x, which was sine x. So this multiplied by sine x plus V2, and this is our V2 plus V2, which is minus secant of x minus cosine of x multiplied by y2, and our y2 is cosine of x. So if we simplify that, we are going to have, so our yp will be equal to natural log of secant x plus tan x multiplied by sine x minus sine square of x plus, and this is plus, so minus secant multiplied by cosine of x, so it will be minus secant of x multiplied by cosine of x. We don't need this anymore. Minus cosine square of x. Now we can simplify this. We know that secant x multiplied by cosine of x will be equal to 1, because secant by definition is equal to 1 over cosine of x. So 1 over cosine of x multiplied by cosine of x is equal to 1. So we are going to have yp equal to natural log of secant x plus tan x sine of x minus 1, and sine square of x minus cosine of square of x minus will be minus 1, because sine square of x plus cosine of square of x is equal to 1, so we're going to have minus 1 there. So minus 1 and minus 1 will be minus 2. So this is the value for our yp. Now we also find yp or ycy, so the general solution to this second order non-homogeneous linear differential equation is equal to yc, which was c1 sine x plus c2 cosine of x plus yp plus natural log of secant of x plus tan x sine x minus 2. So this is the the general solution to this differential equation. As I mentioned, if you write whatever you need on a corner of your page, it will make the problem a lot easier. I hope you liked it. Let me know if you want to solve anything.